Neural architecture search, by the way, for those of you who aren't familiar, is basically if you imagine a machine learning engineer building a neural network, you would go and implement it in PyTorch, right? So that you like compose the nodes, the input output matrix, the weights, and then you define the activation layers, and you basically create like an MLP yourself, right? And you could do convolution networks like RNNs, transformers, that type of stuff. And neural architecture search is basically this idea that, maybe you define like a core module as an ML engineer, but then like there's some meta optimization process that tries to create the network for you, right? So it not only tries to optimize the weights of the network, but actually tries to create the overall structure of the network that best fits this problem. There's a lot of research going into this that has gone into this in the past. I haven't really kept up with recent research. And like, there is something very powerful about this overall idea, which is basically you can optimize at higher levels of abstraction instead of a fixed architecture. And because once you have like a larger parameter space, like there's just going to be like a more globally optimal solution. And that's basically the same here with RAG. It's like you have LLMs themselves, which, are already pre-trained on large amounts of data. We optimize parameters on this data. But once you build LLMs as part of this overall software system, like a retrieval augmented generation pipeline or an agent, there are going to be pieces in there that are going to become relatively standardized, like a stack. This includes like data loading, chunking, embedding, all the things you mentioned, retrieval. And all of these are going to have parameters that aren't easily fed to some backprop algorithm. And so, yes, like either the data scientist or the machine learning engineer is going to have to go and tune all these parameters and basically have a terrible time doing so. Or there is going to be best practices that emerge. So just good defaults, I think, are actually pretty important. So that roughly speaking, if you just set this up using them like with good defaults, you won't really need to tune it. But two, like basically some button that you can just click that will just optimize this a little bit more over your data set, and it will just work over your data set. I do think that's going to be like a big thing in the future, because I don't think that people really enjoy this idea of having to tune everything. I think people would much rather spend time, writing any sort of custom logic that actually relates to their end use case instead of having to fiddle around with like chunk size.